All right, you guys, please forgive the improvised nature of this, but this is very important. I really want to make sure you understand this. Now, this diagram represents the evolution of layered Earth's atmosphere. Whenever you get a graphic like this, always read what the axes say. If you look on the bottom axis here, it says time. BYA means billion years ago. So 0 billion years ago would be now, all the way back to the beginning of layered Earth. This axis here says concentration of gas in percent. Remember, these gases have to add up to be 100%. Now, a lot of students have trouble reading this side of the graph. If you look at this, this is water vapor, water in the gaseous form. We have about, 10% water vapor. All right, now if you notice this, it goes up to about 24, 25%, then that would mean that this would be about 14% carbon dioxide. Yeah, we did have a lot of carbon dioxide in early layered Earth's atmosphere. All right, then you read this, and I'm just going to guess. Let's say 54%, right? Because if I'm at 24 here and I'm at 76 here, about. This is kind of a little bit of a guessing game. Obviously, there's wrong, but there's a lot of kind of right answers. All right, so let's look. And remember, water vapor, carbon dioxide, and nitrogen. Those are the products of volcanic outgassing. So because early layered Earth was still going through the whole process of, kind of settling down, volcanic gases were being released like crazy. And the main gas that comes out of volcanoes today is water vapor, nitrogen, carbon dioxide. And these are the gases. They're heavy. The Earth is big enough to hold on to these with its gravity. All right, so you might notice that, think about this, if this was your investment portfolio, you'd not be very happy. It's decreasing. And also notice this, carbon dioxide is going to decrease too. Now, nitrogen's always been the main gas in layered Earth's atmosphere, and we're kind of going to ignore it, except we'll note that we're going to have nitrogen in early layered Earth, okay, and in present layered Earth, okay, we're also going to have nitrogen. So that's a product of volcanic outgassing. It's always been a major gas. But what we need to do is we need to talk about where did the carbon dioxide go and where did the water vapor go? Because you can see that they decreased to amounts that are even less than would be depicted on this graphic. All right, water vapor. Water vapor actually rained out. Remember, when water vapor cools, it condenses, and it actually rained out to form our oceans. Okay, so that's pretty easy. Now, carbon dioxide. You guys notice these changes are happening. These are billions of years. Think about it. If you had $1 billion in your bank account, you would be a very happy camper. That is a lot of money, and that's a lot of years. So, later on when we talk about, the amount of carbon dioxide in our atmosphere and how it's changing, we're going to be talking about 100 years or less, not billions of years. All right, check out carbon dioxide. It's decreasing too. If that was your investment portfolio, once again, pretty sad. Now, I need to point something out. Right here, about 3.8 billion years ago, life evolved. And again, that life was photosynthetic archaeobacteria, very ancient bacteria. And when life evolved, it had to feed itself. Remember, no Arby's or Denny's or McDonald's to go to. And it did so through the process through photosynthesis. But if you notice, between the very beginning of layered Earth and 3.8 billion years ago, carbon dioxide was already decreasing. And the very first place that carbon dioxide left to is in the formation of limestone. Now, we are going to be talking about calcite, which is the mineral that makes up the rock limestone. But that forms limestone. And limestone's formula is CaCO3, calcium carbonate. And you guys can see that the CO2 went in to the CO3 or carbonate group. All right, and then we can also explain that some of that went into photosynthesis. Now, you guys, photosynthesis, extremely important. Carbon dioxide plus water vapor, okay, with the energy of the sun. Just make sure it's on here. Okay, I'm going to push it up a little bit. Carbon dioxide plus water vapor, energy of the sun, I'm not balancing it, don't worry, forms sugars or carbs, plus a lovely waste product, oxygen. Okay, this is photosynthesis. Okay, now where did the oxygen? Oxygen is 21% of present day Earth's atmosphere. And that's exactly where the oxygen came from. These early photosynthetic organisms created that oxygen. And what you'll want to notice though, look here, this is where the oxygen first started to accumulate in the atmosphere. And you might say, what happened to that billion plus years of oxygen? And what happened to it is it reacted with metals. Remember, before this time there was no oxygen. It was an anoxic or oxygen-free atmosphere, so no metals were rusting or oxidizing. Okay, oxygen starts to be created, and oxygen is an extremely reactive molecule. You know that if you've ever been near somebody who's breathing oxygen, the tank has all sorts of signs on it. No smoking. Okay, things that explode are reactive, and oxygen is extremely reactive. And so that first about billion years of missing oxygen, went into forming a rock called banded iron formation. And you guys will see pictures of it, and I'll talk a little bit more about it in another place. All right, so this is how layered Earth's atmosphere evolved over time.